All right, let's go ahead and get into our Module 6, which is functions. We're going to talk a little bit about setting up your function, prototypes, and then we're going to get into one of your assignments to get you set up for that with a demonstration. Some of them we won't be able to get to in time. I would recommend 6.13 and 6.5, passing data by value. We'll definitely cover passing by reference. We'll demo that given time. And then most of the 6.1 through 6.5, but definitely cover everything in here. So modular programming was kind of the first thing about breaking up programs into smaller, more manageable pieces and functions, and the idea that we break them up into their own little siloed problem-solving functions that do a job and do it very well. And that's the whole idea of functions. They do one job and they do it very well. And then what you can do is you can reuse those functions to improve your maintainability, and also it simplifies writing future functions. And there's a lot of functions that are pretty much standardized in like C and C++ that are also standardized in other programming languages. And of course, those functions were built by programmers for you to use. So it's a big idea, and you're even using those functions today. So when you're working with those functions and building your own functions, we have two parts of it. There's the first part, which is where you define the function, and then the second part is you actually call the function. So there's a difference between the definition part of a function and the runtime part of the function. And when I say runtime, that means when your program is actually running and going through each line and processing it. So you have that for the first part, that function definition. You have a parameter list, a body, a return type, and a name. And the body is where the runtime code happens. The parameter list, the name, and the return type, that is part of the definition, but the return type is part of the runtime also. So you first have to define the function and then dictate what it does, and then you call that function definition with these four characteristics. Here's an example of a function that you've been using quite readily called main. It has a name. The parameter list is where you can send it arguments. argc, argv is a main argument for the main function. It's used a lot in the Unix, Linux, C language. In fact, the whole Unix, Linux operating system runs on C and these type of functions, and then a return type. So let's actually get into that a little bit and delve into our fun for today, which is going to be playing with the is even, or building an is even function. So it's going to be close to the is prime, and in fact I'll give you a little primer for that, pun intended, to get you in the direction of solving that. We're going to do something very similar called the is even function, and then I'll kind of give you a little tip on where to go for completing that is prime function. So let's go ahead and go back to the PowerPoint, and then we'll get into some code here. The function header consists of the function and return type, the name, and the parameter list. Okay, let's go do a header. The header that we're going to be doing is called an is even function, and what it's going to do is it's going to take a number and it's going to return true or false on whether the number is an even or an odd number. So we're going to use it. We're going to build it using the modulus operator. So let's talk about that real quick first. To detect whether a number is even or not, we can mathematically divide it by 2 and get the remainder of it divided by 2. And if the remainder is a 0, then that means that the number is even. If the remainder is 1, then it's odd. So you can just take any number, divide it by 2, get its remainder, and that'll be a 1 or a 0, and that tells you which is even or odd. And let me demonstrate that. So the modulus operator is what we call the remainder operator, and it actually takes for this line, the line on line 13, it takes and it outputs the remainder of 1 divided by 2. So what's the remainder of 1 divided by 2? 1 divided by 2, so basically 1 divided by 2 goes in 2, it goes in 0 times. It's not able to be divided, so it's 0 with a 1 remainder. 2 divided by 2 goes in once, but its remainder is 0. Then you go to the 3 divided by 2. A 3 divided by 2, the 2 goes into the 3 once with a 1 remainder. 2 goes into the 4 twice with a 2 remainder. 2 goes into the 5 twice with a 1 remainder. So we got 1, 0, 1, 0, 1. And then if we did 6 mod 2, it would be 0 again. 1, 0. So every number, its remainder, no matter what, if we take it and divide it by 2, will come down to a 1 or a 0. And that's how we can determine is even. Now what I'm going to do is we're going to start the function in a place that is not the best place to start it, just to talk to you about what we call, well, basically it's how you set up your functions. And one way to do it is where you have your main at the top and then you put your function at the bottom. Now for this function it's called the isEven function. So, but this is a function that's going to take a number. So I'm putting a number that it's going to take into the argument section. Now notice how I'm declaring it an integer and I'm saying number, because this is defining the function. Then I'm going to say that this function is going to return a Boolean. It's a true or not, whether or not the function is even or not. And so this is how we kind of form the function. Now, there's a problem that I've created here, but I'm going to just say, hey, return 0, false for now, just because we're going to finish it, and then we're going to play with it. So we see here that this isEven function returns a Boolean, takes on a number, and we need to decide whether or not, hey, is this number that's being passed is even. So I've got the function header part. I've got the name of the function. I've got the arguments that we're passing to the function, and then I've got the return type. You don't have to. You can say it's a void return type. This is the part of the definition part of the code. What it returns, its name, and then of course what it accepts as an argument, what it's actually going to work on. It's going to work on something that we send it. It's going to return the answer. Okay, now we look at this and everything's fine until we decide to do something like this. If is even 11. So that's how we use this function. But we could do something like that. Bool k is equal to is even of 11. Okay, now I can just look at k. So that's just a shortcut. So when I do that, I'm saying run the function, take what it answers, take the answer, which is k, and put it here. Okay, so let's just run it that way for now, because that's probably a better way for you to look at it and determine it. This is runtime code. This is actually doing something. It's calling the function. But we've created a problem because this isEven function, main doesn't know about it yet. It has no idea what is even. You can see here one error, is even identifier not found. So then that takes us into where we have to declare the function is even up here so that main knows about it. And this is just a prototype, and it does nothing. It does nothing other than tell the compiler that the isEven does exist, but you need to find it. And this is just telling the compiler not to shoot this error to you, is even identifier not found. So we do a little quick prototype so that main can deal with it. And so what we'll do is we'll just do a header without the body. And it just needs int at top. It just needs to know that it's taken an int. Okay, so now the compiler will will be fine. Here's what I want you to do. I don't want you to use prototypes ever. This is so difficult to learn when you're just to work with on learning functions that I just suggest you don't do it. They're actually useless, and they're not really top-down programming the way it should be done. The way it should be done is main should be at the very bottom of your program, and all your functions should just be above. And then you don't have to deal with stupid prototypes. Prototypes are useless. Well, I mean, they're not useless, but they're useless. Okay. So anyways, so as long as you have your function above main, you don't have to do your prototype, and that's true top-down programming. So this is now going to go ahead and compile. Okay, so we have our name, our argument, the return type. We are calling the function, sending it to the data, receiving the answer to a variable that we create. It doesn't have to look like that. We can just do k equals also if we want to. So we're going to run through the debugger on this and test it. Let's go through some more PowerPoint. Okay, so here's an example of a non-value returning function. Notice the void here, and all it's doing is printing a heading. I would recommend not to do any input or output in functions. Functions, I mean, from the user. You shouldn't have cout or cin. Well, if you do have a function that just prints stuff, that's fine. But you don't want to do much. You want to do as much of your data input from the user and your output in the main. Functions are to do a job. Some of those times, those jobs are just to print and get data, but it's not the best to get data from the user in a function. Okay, so then you call the function, that print heading function, and here's an example of calling it. Notice the semicolon there because that's an actual line of code that you put in the body. Okay, so main is automatically called when the function starts, and what main is used then for is to call any other functions that you create or functions that are created by somebody else. Okay, functions prototypes, we just talked about them. I'm going to move on. You can get into that one. But here we go, setting data into a function through an argument. Here's an example of data being in a function. Remember, you can actually do more than one parameter of data. Our isEven function just does the one. Okay, so what I'm going to do here is I'm going to set a breakpoint. We're going to look at what actually ends up happening. Okay, the isEven is called here. I'm going to do a step into, and this is going to take me into the runtime. I pass in, and we see that number is coming in as the value 11, which is what I'm passing here. Then that is it. Then we're just returning false. So k is going to look at, let's go look at k, see it's false, so it's going to ignore everything in here. What I'm going to do is I'm just going to, let's just add a little bit more to this. And I'm going to do a cout, yes. And then, well, you know what? Let's output this. And then we'll do an else. And then we'll do k is even, k is odd. Okay, now this isEven function needs to be finished, and that's really easy because what we can do is we can just say if the number that has been sent to the function divided by 2 and its remainder is equal to 0, number divided by 2's remainder equals 0, then that means that it's even. So I'm going to return true. And only if that function hits, this hits is true, and we return a true, that means this return never is gotten to. But if this function fails and it does have a remainder, then that means it's an odd number. It's going to fail and skip over this return true and then return 0. So it's going to do a yes or no, basically. So it's completing the job. So let's go ahead and look at this guy. Do another step into. Step into. Okay, numbers coming in as 11. Number mod 2. We can look at number mod 2 and just do an add watch here. And we see here down here at the bottom, number mod 2, value is 1. So it's not equal to 0. So that's going to go all the way down to return 0, which is false. Oh, by the way, yeah, just return 1 or 0. Guess what? Just true and false is just 1 and 0 behind the scenes. So I just don't even mess with it. One is true, 0 is false. That's a computer science mainstay. Okay, so that is working properly when we have an odd. It returned our 1. When we have an even, okay, when we have an even, it returns a 1, and 1 is even. 10 is even. Let's do an end line here, because we're going to extend this here in a little bit. We're going to go back to the PowerPoints here shortly. Okay, so breakpoint set, debug, start debugging, step into, number comes in as 10, number mod 2 is going to be 0, returns true. And then we say k is even. Oh, output 1 is even, k is even. Yeah, I'm going to play with that, but it would be 10. So what we're going to do is we're going to do this. We're going to do an int num equals 10, and we'll put here num, and then here num, and then here num. Because we're going to extend this, and we're going to say, okay, let's take a little bit of your Boolean times here, and let's say here that for int, or how about this, num equals 0, num is less than 100, num plus plus. Okay, and then that whole structure should go in. I don't think I need my things because that whole thing should be part of the if. And when we run this, it's going to output whether, which ones are odd or even. At least I thought it would. Oh, duh. Num is less than 100. There we go. Now, yeah, let's go ahead and do it. Even though I probably don't need to, but that's fine. Okay, there we go. We're testing all the numbers now. Okay, 70. Okay, well, it looks like we've got some issues here of whether or not this is working correctly. But what we've done is we didn't rerun this is even every time through. So that has to be here. And why are we even using k? We don't need to use k. The heck with that. Let's just throw the is even function in there and it'll take the return type. Just like that. But you know what? While you're learning, guys, do that. Be overly, don't do the shortcuts as you're learning. And if you see something that looks a little odd and you don't know exactly what's happening, put it in the compiler and look at it and see what's going on. Okay, so now this will do our is even. Okay, is even is odd. Okay, that's all working right. Okay, so the next thing we're going to do is I'm going to give you hints on how to do that with your is prime function here. We're going to go into that as soon as we get our PowerPoints taken care of. Okay, so this is a sending data to function. I've just demonstrated that. Functions headings and prototypes. That we just covered prototypes. A little bit on why you need them. Go ahead and read up on them, but don't use them. You don't have to use them. I don't care if you use them or not. function call notes. Okay, let's get on with calling functions with multiple arguments. This is a good one. So this is a function prototype for. Oh no, that's the function call. Excuse me. This is the function itself. Notice how they put the comma here, separating the different parameters that are going to come in. Now notice also that height and weight are not H and W, because it doesn't matter. It's taking and it's making a copy of the height and the weight. And so this is where we get into the pass by reference, pass by value items. It just makes a copy of it. So let's get into that here. No, we're going to get into that in a second. Let's come back to this guy right here, and I'm going to show you what to do for your isPrime function. I don't want you to engineer a new mathematical way to determine whether a number is prime. No, just go out and find something that's already built. So like do a C is prime function search. And just look at something that that is already done and get the mechanics of it. So I see here that we've got some code. Here's some mechanics. This one does not look very good. It doesn't actually return a true or false. You could, this is a program to check for a prime number. It's not a function. So here is a good function. Now this one looks much better. So what you could do is you could just take this, copy it, put it in here, and rename it isPrime. That's totally okay code to grab from. That's not cheating. That's using a already built algorithm for something very common for a common job. So you would put that code in there, get it to work, and rename it isPrime. Fairly simple, guys. Here's the example on how to do it right there. And to get it working. Okay, so that one I don't consider cheating. Now if it's a like a whole program that doesn't it's not like a function that just does one thing. It's a whole program with many functions that you're supposed to author, and then you grab that whole program and then convert it and change things. That's kind of cheating in some ways, but not really, because you can use that code as an idea of the direction you can go. You can't use the code literally, but you can give it some thought and then come up with your own solution. Okay, so let's get into calling functions, the pass by reference versus pass by value. That's where most students have their problems when it comes to calling functions. So what I'm going to do is I'm going to call this one name change me. Okay, and I'm going to say int number 2. And then this one actually is going to be a void. Okay, now when we use this guy, I'm going to call change me, and I'm going to send it 2 numbers. An integer called I equal to 10, and an integer called j equal to 1. Okay, and then I'm going to send change me of I comma j. Now notice they're not the same name as number and number 2, but since I'm sending I, it's going to be called number. Number 2, I'm sending j, and it's going to be called number 2 when it comes in. Okay, so then what I want to do is, let's say I want to set number equal to 3, and then number 2 equal to 5. Okay, and then I'm going to output cout I, cout j. So what I want is I want this function to change the values that I send it. And then I want that change to show up out of scope, which means that I have to do what's called pass by reference versus pass by value. By default, this is a pass by value. So what ends up happening is I comes into this number, but number is not I. number is made a copy of I. So when you come in, number is a separate address than I. And you can kind of, if I can get my whiteboard up here and power it up, we will begin with a little bit of that. And evidently I got to plug it in. There we go. Okay.
Playing from R2.
No, you silly things. Okay. New whiteboard. Okay. All right. So let me give you kind of a little bit of a visual help here. Okay. Yeah, if I can figure out how to use this silly whiteboard. Okay, so right down here when we send I itself is a variable on the stack, and it has an address in RAM. Let's say it's like at address 300. It exists, since I is an integer, it exists from address 300 to 304 in RAM. And I is going to hold a value, and the value that we're putting in I is 10. Okay, so what happens to both I and j is when I is sent to the change me function, it is not I. It becomes a variable called number, but it's on RAM in a totally different address. It's like at address 600. And it's just going to take what's inside of I and copy it and put it here, 10. Okay, and number, the same thing happens to number 2 and j. So j is made a copy with a whole nother variable with its own address. So that's called pass by value, because what happens is we're just taking the value that's inside of I. We're taking that value and we are copying it to the variable called number and putting 10 in it, which is at address 600. So let's run this code and let's look at what happens. Okay, I'm going to do a step into here. I'm sending I and j. I is 10 and j is 1. So I do a step into. We see that number has 10 and number has 1. So then I changed number to 3 and then number 2 to 5. Okay, so then that goes up here. So up here on the whiteboard, number got changed. Instead of 10, it got changed to 3. But you see, we're changing the copy at address 600. We're not changing what we sent it. We're not changing I, because that's been made a copy of. So when we come back out of scope of that function and we output I, it's still going to be 10. It's not going to be 3. Because of that copy that was made. That first output 1, 0, that's the 10. We must have another output here for something. Okay. So the pass by value only makes a copy of it and makes this a truly what we call kind of a read-only function. It doesn't really have access to anything we send it, write access to it. It just can read the data and act upon it. Now we change that to passing by reference. And when we pass by reference, we say that I'm going to send you an address of a number. And then you pass the address of that number with the ampersand. And we're going to see some different behaviors. I believe we can do pointer. We can use pointer for the pointer. Yeah, let's just use the pointer. We say that we're going to use the address of the number, and we send it the address of the number, and then I say go to the address of the number with a dereferencer, and assign it to 3. 3, yeah. So let's go here. So we take the address of the number. So we got to dereference that. Okay, so what's ended up happening here is this whole thing changes now. Instead of I being made a copy and being made 600, we're saying no, don't pass the address of I. So what we're saying is don't pass what's in I, pass I. Because the address is I. It's a physical representation of the variable I. Even though we're calling it number over here, that's fine. But we're passing that address so that when we access it, we're going to go and be able to change the actual value of I to 3 instead of just changing a copy of it. And that's called pass by reference. And there's different ways of doing pass by reference. I'm showing you one way to do it with pointers and dereferencing. Your book will show you another way that's a little bit easier. But, we might as well get into pointers while we're at it, talking about them. You'll learn more about them in 162. But this pass by reference changes behaviors because now when I change it at line 13 here, I'm changing the actual variable that we sent it. So now my function is doing more for me. It can actually act upon memory that I send it and change it versus being read-only. So now this is a write function. This is a function that can do write behaviors. And this is a pretty big standard across all programming languages, the ability to do pass by value versus pass by reference. And it's probably the most important thing about functions in the whole chapter, which is why we're spending the time on it. Okay, now let's look at the behavior and how that changes things. All right, so now I get in here and I'm passing I, but not just what's in I, I'm passing the whole of I. I do a step into, and I have to dereference the pointer and say go to the value that's stored at that address and change it and assign it to the value 3. Then it goes in, and it comes back, and now I should hold 3. And it does. Look at that. So it actually changed that. Excuse me. I've got a little bit of some background noise going on. All right. So the idea of the pass by reference and having a function that can actually change a value for you is a big part of programming. So whenever you see like the address of, know that you're working with a pass by value or pass by reference with a pointer versus a pass by value. So let's look at that one more time. Okay, the change me function runs. I do a step into, I pass it I, not just what's in I, but the whole variable I I'm passing. It gets I, changes it to 3, which means that it changes it in the outside scope. And it comes back when it's done running. Now I has 3 and it's been changed. So that's write access of a function. Okay, let's go back into some PowerPoints here. Passing data by value, parameters, we did that. The return statement. You can only have one return statement, and you can return multiple different types of data, but usually you're remanded to one return. You can't return multiple things, just one. Okay, and you can do some fun things with the return statements, and let me give you an idea of that. So let's say that we're returning an integer, and we just want to take 2 numbers and add them together. Well, we could say integer x is equal to number plus number 2, and then return that integer x. Or we can just say return the number plus number 2. And what will end up happening is the 2 numbers will be added together into a temporary variable that is given no name, and then that is returned as the sum of those two numbers. So return statements, as long as they evaluate, as long as the expression evaluates to the data type singularly that is being returned, then you can do these types of things, you know, where you can have an expression happen before the actual return. So before things are returned, number is added to number 2, which is added to 3, which is added to 2, which is one variable that is returned, which is the sum of all these numbers. And that return comes back to an integer we can call k here, and assign to change me. And then what we can do is we can do a cout of k, which will give us the actual number. Or we can say, oh, the heck with that. Why even return k back when I just want to output the return value of it? So we'll just put the cout of the function. And then the function runs, and the return value of that function is what is output here. So those are different things that you can do with return values. They can be explicitly assigned, implicitly assigned, the return value being what cout outputs is the return value of this function running. So that means this function runs before the cout is done. It has a higher precedence. Okay, you guys can play with a multiple argument list. I've hit all the things that I've really, that I really wanted to get into. The pass by reference and pass by value is the main one. Local variables and global variables, that's one we have to hit on. Okay. So up here, we notice here that I have integer I. Well, I cannot use I up here because I only exists inside of this function main. Okay, and if I have an integer here, called k, I can't use it over here because k only exists between this first part and this last part, the start of the function and the end of the function. So that's the scope of k. It only exists when this function runs. That's when it's loaded onto the stack. So we can't use it out here. However, if we have a variable at what I call file scope, this is function scope, this is function scope. File scope, like an integer called L, that you notice how I put it at the top. I can use L everywhere below, and I can use L in main too. But we're working with the same variable that it's at file scope. So now every function in this file has access to that variable called L. Now, this is what we call a global variable, and we don't usually want to do this because it causes a lot of problems and also tends to have students use bad practice, program inappropriately, because global variables can be a nightmare for problem solving with bugs and logical errors. So it's very much encouraged that you don't use global variables. Pass the data and return an answer. Now, if I put this L all the way down here, if I keep putting it, I put it all the way down here at file scope, now these guys won't have access to it because it's below. It's below. It's declared below. So now the compiler does not know what L is, and that's where I see it says L undeclared identifier. So that's why you put it up top. And that's true top-down programming. So we put our global variable used by our code at the top. And now the compiler sees it, and when your function gets in there, the compiler sees L being used, it knows what it is, and knows at what scope on the stack it belongs in. It belongs at file scope, and it's able to work with it. Okay. So here's a really important part of that. A local variable only exists while its defining function is executing. Okay, let's run this. All right, the program runs. L goes on the stack. Okay, so the program is running, Let's start it out and let's talk about what happens on the stack. The stack is just your memory that's assigned to your process to be used automatically. And so when you declare a variable, you're using the stack, and that variable goes on the stack. And the stack is like Granny's buffet stack of plates. It goes in first in, last out. So let's look at how the stack behaves. Okay, so L has already been compiled and is on the stack. So we've got L that goes on the stack. So L goes on the stack, and it's a global variable that's accessible to everybody. So L is on the stack. Then I, so I'm on line 21. It's being processed. I goes on the stack. Then this line runs. Oops, let me run it again. We're at I being on the stack. Okay, so I goes on the stack. Step over this one. J goes on the stack. So J is on the stack. So L, I, and J are on the stack. Then I do another step over. We run a new function. Change me. It's running. K goes on the stack, but in a different scope. So I'm going to K goes on a stack at a different scope. L is on the stack, so we can access it. We know it's there. We cannot access I and J because L should be over here because then it's accessible by all. I and J are only accessible inside the main function. Okay, we get done with running the change me function. The change me function runs, spins up K on the stack. It gets done running. It comes out, comes back to its calling point, to line 24. And K comes off the stack. It's gone for until change me is called again. So it's gone. K isn't on the stack anymore. It's totally gone. We're back in the scope of main, and we have on the stack J and I. Okay, so then main gets done running, and the function comes out, and then J and I are taken off the stack as well as the function called to main. And so once the function gets done running, the main function gets done running, then these guys all come off the stack and everything comes off the stack because the program's done running. So that's kind of the idea of the way a stack works and calling a function and what happens. So that's a key important note that any local variable, it only exists in the defining function when it's executing. That's the only time it's loaded on the stack. So when the function terminates, those local variables are destroyed. Okay, you guys can get into static and stuff like that. Default arguments you can cover on your own. I gave you the pass by reference, pass by value are important parts. Now your book, I told you your book has a different way of doing it. This is an example of the different way. It looks like we can do it simply or more simply by just putting an ampersand here. And that's all we need. We can just say number equals 3. That's the easy way of doing it. I did it with the pointer and dereferencing. That's fine. But this is the way that the book wants you to do it for now because it's the easier method of doing pass by reference. Okay, I think everything else you guys can take on your own. I gave you clues on how to do your isPrime function. Yeah, you can use that on your assignment if you finish it out. Thank you much.